Hello, today we're going to talk about how the universe will end. Um, let's make sure we're all on the same page here when we're talking about the universe and make sure, we're all thinking the same stuff. So we've got the solar system, which is, where we live. You got the sun and all the planets and stuff like that. And you go the next scale bigger, you got galaxies. So the galaxies made up of millions of different solar systems. Some of them have planets, some of them have more than one sun, lots of different things going on. But, that's the next scale up. And then the next scale up again is the universe. So we got a picture here on the right. It's originally called the Hubble Deep Sky or Deep Field photo, but this was taken from James Webb. So almost everything you can see in this photo is a galaxy. So when we're talking about the universe, we're talking about lots and lots of galaxies. It's the biggest scale that we know, and everything that we know of is inside the universe. While we're talking about this photo, I guess I'll point out, so you can see some of them have these beams of light coming off them. Those ones are stars, and that's to do with the shape of the mirrors from James Webb. But everything else is a galaxy. Okay, so when we're talking about the end of the universe, there's two main different scenarios that can happen. So let's talk about those. So the first one is called the heat death of the universe. So the universe is expanding. So since the Big Bang, when we had a single point and everything kind of exploded and started expanding out of it, all the stars formed, all the galaxies formed, everything kind of got made. What happens if everything keeps getting further away from each other and keeps expanding and getting bigger and bigger? So the easiest way to imagine this, to put this into context, is imagine you're standing on a balloon and there's several other people also standing on this giant balloon. As the balloon inflates, every point on the balloon gets further away from each other. So it's not like, it's not like, say, you're putting out a tape measure or something, and things are getting further away from you. Everything's getting further away from each other, so there's no center of the universe. So when things are getting further away from each other, everyone's getting further away from each other. There's no getting closer to each other. So what this means is galaxies will get further apart and can't interact with each other. So what happens is when stars are born, they're made from different bits of gas and dust that kind of pile together to make stars and solar systems. These bits of gas and dust come from within the galaxy. Eventually they will run out. So what happens at the moment is the galaxies will eventually run into each other, they'll collide with each other, and they'll make new gas and dust as they kind of smash together. But what will happen is, as the galaxies get further away from each other, they can't smash together, so eventually they'll run out of material, run out of fuel, and so they can't make any new stars. So what will then happen is you'll have our nice night sky, and it will slowly get darker and darker until there's just nothing left, and the universe will be a very empty place. This would be millions and billions of years from now, but there would be nothing left, and so eventually all the light would go out in the universe, and there would be nothing. So very depressing, but we're talking about the end of the universe here. So scenario 2 is called the Big Crunch, and this is pretty much the exact opposite. So let's say you're pulling an elastic band, right? And you're pulling it and pulling it and pulling it. And eventually, if you let go, it's going to snap back to where it was. So what happens if that could happen with the universe? So everything at the moment is expanding. What if eventually it stops and then starts going back in again? So as I said, we'd have the exact opposite. So rather than these galaxies getting further away from each other, they'll start coming back together again. And so the universe would basically get smaller, and there would only be so much space for everything. And so this would literally be the opposite of the Big Bang. So you go from everything being far apart, everything squeezed in together. Things would get really weird as well, because you would have a lot more material together, so you could potentially have bigger stars. You'd probably get a lot more black holes around. But eventually everything would probably squeeze back into a single point, and we'd probably have our Big Bang. So one of the theories about the Big Bang is that it could actually be a series of Big Bangs. So we have this whole thing of our universe kind of being created, going up into a certain size, and then coming back down again into a single point, and this kind of just happening over and over again. But this would be over, billions and trillions of years. So it'd be hard for us to see that pattern. But that is one theory. How do we know which one of these will happen? Well, the answer is we don't know. There is also a third theory that I haven't really mentioned, called the steady state theory, which is that the universe could just stay the same as it is now, and kind of nothing really changes. but that seems very unlikely when we're looking at the space and like how things are moving like that. So the best way to know which of these kind of 3 scenarios could happen is if we take really accurate measurements of how fast things are moving away from us, and then we can hopefully work it out. So there's 3 satellites that are kind of working on this at the moment. Well, 2 of them at the moment, and 1 of them's coming. You've got the James Webb Space Telescope. So this is looking much further away than anything we can at the moment. So a lot of these telescopes are using infrared light. So you might have seen infrared cameras that can see in the dark. So we can't see infrared light with our eyes, but this is what these telescopes are kind of taking photos with. So they're looking at things that aren't visible to us, but are giving off a lot of light. Because when you look much further away, you see a lot more infrared. You also got Euclid, which was launched last year, and that's trying to take like a big survey of like the whole sky and trying to find some really far away objects and measure. And these are both measuring the distances to all of them. And then you got the Nancy Grace Roman satellite that's kind of coming in the next couple of years. This is quite a big one. This is supposed to be able to look like quite far away. It's specifically designed for looking far away. Whereas James Webb's kind of a bit of everything, and Euclid's trying to do like a big like survey of things rather than looking in specific places. Whereas Roman's gonna be like pinpoint accuracy kind of thing. And so yeah, all 3 of these are kind of looking and measuring distances to galaxies and stars and stuff like that. I can talk about that more in the future if you like. That's kind of what my PhD is based on. So yeah, and then our kind of observations at the moment of everything we know is it looks like everything is kind of getting further away from us faster. So it looks like the expansion of the universe is speeding up. And so yeah, it looks like we could be going towards the heat death of the universe. But again, we're not sure. Who knows what's going to happen next? It's the universe. It's a very mysterious place. So anyway, yeah, thanks for watching. And if you like this video, maybe you want to check out one of my other videos. I did a great video on talking about where exoplanets come from and everything we know about planets in our solar systems. So check that out.